Hello and welcome to the Spatial Structures Movers and Shakers interview series, as we look ahead to the IASS Annual Symposium and Spatial Structures Conference, taking place at the University of Surrey in August 2021. My name is Mark Richardson, and today I'm joined by Olga Popovic Larsen, who is a professor at the Royal Danish Academy of Fine Arts, Schools of Architecture, Design and Conservation. Olga is also the chair of the working group of the teaching of spatial structures at the IASS. Thanks very much for taking the time to speak to us today, Olga.
Yeah, hello, Mark. It's a pleasure.
Very nice to have you on the programme, Olga. Thank you for joining us. So we start by asking about the lockdown period, and perhaps you could tell us, how has the lockdown been for you in Denmark?
Yeah, it's been both fine and difficult. It's been fine because we realized how much we can do without having access to work and the school and being at home. How much we can do today with digital tools. But we have also found many things that matter that were actually very difficult. With our students, we spend a lot of time making models, so not having access to a workshop for them and for us was very difficult. Also, we found that tutoring online wasn't the same, because normally we would sit in a group and then we would sketch and we would talk and we would share drawings, and that was very difficult. We did share screens, but things took longer. However, having said this, it was all possible, and that's really amazing. But on a kind of human level, we also found how much the social relations mean to us, how much it matters meeting people. I realized actually that it although takes me a long time to get to work, on the way to getting to my office, I talked to many people. So all that disappeared all of a sudden. But having said this, there were some positive aspects too. One was that it worked. I think being at home and being isolated helped everybody. But also that the hour and a half or an hour going back and forth to work was now a time that belonged only to me, that I didn't have to spend on public transport. So I started doing more things that I don't usually have time to do. So that felt special. So it was fine and difficult, and we're really encouraged that now staff are allowed to come at the university. Our students are still not back. Only some of the exams could be physical, and we're also preparing for the autumn that a lot of our teaching will be online.
Great, thank you very much, Olga. And we're also exploring the career journeys of our participants on the series. Would you be able to give us an overview of your own career journey to date?
Yeah, I've kind of moved around a lot in my life. I come originally from Macedonia, that was part of Yugoslavia then. And there I went through high school, gymnasium education that was kind of an experiment at the time. It had a lot of humanities and a lot of technical subjects at the same time. So the nice thing about that was I could choose a career in either. And I must say I really enjoyed math, but I also really enjoyed art and writing. So that led me to do architecture that is slightly different to what we have in the UK, and especially very different to what we have in Denmark. It's more technical. It's a little bit more like a German type of degree. And then throughout my studies, I got really interested in structures and materials. And there I met a professor who, in a way, was a role model, who was both an architect and engineer. And he encouraged me to continue. So I did also a master's degree in engineering after completing architecture. And then I worked for some years, both in practice and teaching and research. And then my journey brought me to the UK. In Nottingham, I completed my PhD on reciprocal frame structures. And then I got a job in Sheffield, spent many years in Sheffield. And after 17 years in the UK, then I came to Denmark, and I've been here since 2008. In all of this kind of I was always really inspired by the lightness of structures and how they contributed to architecture, how the structural solution was so important. And then I kind of had, throughout my career, had the possibility to study these heroes with their beautiful buildings.
Great, thank you for that, Olga. And you mentioned there your PhD in reciprocal frame architecture.
Yeah.
Was there a particular structure or role model in this area that sparked your interest in reciprocal frame architecture and structures?
Yeah, perhaps it kind of goes further back. I was really inspired by the lightness. So like buildings like the Schuhof Tower or the Pantheon that could span so far, and then kind of understanding grids, but and how there is a clever way and not so clever way to have a grid. Um, uh, so kind of both from history and contemporary architecture. But reciprocal frames became an interest. I was at the School of Architecture in Nottingham, and there was an American master student who was in the same space as me. She was working with reciprocal frames. She actually decided not to continue, sadly, but we were in a time before the kind of parametric tools. So a lot of the work was through Excel sheets, understanding geometry. And I couldn't really understand the physical meaning. So I started helping her make models. And then when she decided to leave her course, then I went and asked, could I do reciprocal frames instead of what I was doing? And that was accepted. So I completed my PhD with supervisors Banseng Chu from engineering and John Chilton, and kind of really enjoyed the challenge of understanding these structures. Now we can do a lot more with computational tools, but those days it was very difficult. So physical models have helped me a lot.
That's great. Thank you very much for that overview, Olga. That was really interesting. And obviously, we're looking ahead to the forthcoming conference. Maybe you could tell us about your experience of attending a previous international conference on spatial structures.
Yeah, so at the time when I started my PhD, I kind of thought a little bit last night, and the first IASS conference that I went to was in Stuttgart. And this was really amazing because Fry Otto was still alive and he gave a talk there. He was obviously one of my heroes, working with models and developing lightness in structures that was also, they were amazingly beautiful, the work, the structures he built. So I could go there and meet him. Then another spatial IASS was in Aarhus. This was just before I moved to Denmark. And there I think I talked for the first time to Professor Mamoru Kawaguchi, who was kind of also one of my heroes. I then met the Scandinavian network that I kind of knew about, but I hadn't met them before. I also, around that time, was the Nottingham colloquium on, what was it called, that was connected to IASS, where I met Professor Newton for the first time, and he was clearly one of my heroes. A more recent one that I can think about is the Hamburg IASS that kind of had a little bit of a new way of thinking with these Pecha Kucha presentations that were kind of really very short and sharp. So for me, it's difficult actually to separate one that was the best. They were all the best. I don't go to many conferences, but I try not to miss the IASS, and I really look forward to the Guildford one.
Yeah, thank you very much, Olga. And as you alluded to there, with respect to Professor Newton, who was in charge of the University of Surrey's Spatial Structures Research Centre for a number of years, and this year the conference is being held at the University of Surrey. Can you tell us perhaps about an experience you had of working with Professor Newton and how that may have inspired you?
Yeah, to me it was really interesting when I was still very young, when I met Professor Nushin, and obviously I knew about his work, but I found him really accessible. It was very easy to talk to him. He was very happy to share his view and to hear my, I would say, very young view then professionally. And I remember that we discussed, there was a building, a tension structure that was built in the UK. And so we discussed the forces, we discussed the aesthetic, and again, to me, it was very special how accessible he was and how easy it was to talk to him. I had the opportunity to spend a couple of days at the Space Structure Center at Surrey University soon after completing my PhD, and that was working together with Professor Nushin and a group. And that was really interesting and inspiring. Since then, I've met Professor Nushin at conferences, and the last time I talked to him was when I was invited to Iran, and I attended a symposium there, and it was very special. He seemed kind of the same as he did 20 years ago. So as if time had stopped, really. And it was so special. And I felt really honored that he had remembered me. I'm sure he's met so many people in his life. So that was very special. I've learned a lot from him.
That's really great to hear. Thank you for sharing that recollection with us, Olga.
Yeah.
So we're now going to move on to the middle section of our interview, which is entitled Your Space, Your Structure. So I'm going to hand over the presentation to Olga, who will be taking us through one or two photos and projects of areas of work that she has been involved in directly or admires in the past. So over to you, Olga.
Okay, so now I'm sharing my screen, and the few shots are actually examples of buildings that have inspired me. So to the left, we see two slides. They show the Schuhof Tower. It's a really lightweight structure from the 1920s. And then we see the Pantheon building, a very clever way of building a long span. And then we see here two grids, and one is Zaha Hadid's hotel, and the other one are Pierluigi columns and a grid concrete structure. And they're very different, whereas one follows the forces, the Pierluigi Nervi one, Zaha Hadid, is only possible because of digital tools that allow us to build anything today. And then my fascination for geometry and form, and this is Utzon's Sydney Opera House, and how he form finds using a sphere the sails of the Sydney Opera House. For a long time, I believed, and I still believe, that it's very important to have a collaboration between engineers and architects. This is a sketch by Corbusier, where we see the two hands coming together. So the work of an architect and an engineer have an overlap, and they have to collaborate. Since this has become very much part of a book that I wrote on conceptual structural design, but also my views have changed a bit, that now I don't think that it's enough to have a collaboration between an architect and an engineer, but the craftsman is really important, yeah? So if we're going to build sustainable buildings, then architecture, structural form, and realization come together and are very important. A recent book that I've just published is about physical modeling, and I've worked a lot with physical models in my life, and the previous work is on reciprocal frame architecture, and I bring them together because both are developed through models. And we use a lot of models in education. They're really important for architects and engineers, because I think especially for architects, because they don't have the background in math and to understand the depth, but also for engineers, because you can see immediately what happens. But actually the book was about explorations of, are physical models important still today in practice, not in education? But coming back to education, our students make a lot of physical models. Here are some columns where we're not only concerned with the forces, but also with the aesthetic. And how better to understand bending active than through a model. Here we see some apples that when they rot, the bending becomes they become lighter, and the bending forces are smaller, so the bending in the column will change. So a lot of things can be seen and understood through models. They're again student work here. But my own work with reciprocal frames was also developed to a huge degree with physical models. And that was because computational tools at the time were not at the level to be easily used. Of course, I use computation, but not so much to generate geometry, but more to draw. Today, we have parametric tools that allow this a lot more easily. Even though we have all this, I still believe that physical models are a good tool to have. So with students, we built a lot of these models where we explore geometry and how they can come together. So reciprocal frames use, the ones I work with always use identical elements that come together in a simple way to create complex geometries and large spans. A project that I would like to share with you is inspired by Leonardo da Vinci. It is a project for a local building in Denmark, and it was the client had a wish to build a farm building, a barn where he would use local timber, not very good in quality, but a structure that's beautiful, that can span a long distance, that has a distinct aesthetic, so kind of too many requirements. So it started with Leonardo da Vinci's drawing, and then it developed into this truss structure. So it's not a true reciprocal frame, but it's based on a reciprocal frame. It is a 16-meter span building, and the wood is really optimized. It could become something else later. It's almost a shame that the cows live in a beautiful form. It would be also equally nice for a little concert hall or a community building. But at the same time, I'm very happy that I was involved, because we could develop something that could be easily built and was optimized in how we used resources. Another project together with colleagues from Belgium was the development of reciprocal frames into bending active structures. They had worked a lot with bending active, but not with reciprocal frames. And myself, I had done a lot of work with reciprocal frames, but not really with bending active structures. So we had a possibility where we could collaborate, and we had just over a year, and we decided that we would build something in full scale. So it started with models, that then we developed this kit of parts that we created these curved plywood beams. And then we built this little pavilion. You see all the members of the team together with myself, my colleagues from BUB, from Brussels, and 2 students from the Technical University. What was interesting to me was that this structure that is truly minimal, it's using only 12 millimeters of plywood to span about 5 meters, was not only beautiful, but also very easy to put together. And then at one point there was a rock festival, and we were invited to have it there. So in a couple of hours, it all came down, and there was nothing left on the site. It came in a little, it was packed down, and it could leave in this little van. And so that has inspired me a lot. And together with some colleagues from the Nordic countries, we're exploring ways of how to use materials that are not so obvious to use. So we have, based on another form of reciprocal frames, this is a real building in Copenhagen. It's a station. So if you look at the timber roof, it's actually a German design by an engineer called Zollinger. So we are exploring with this type of structure how to create connections that are very simple, but we're trying to utilize materials that are otherwise waste. And then the other aspect that I'm really interested is that we look at what is the cultural value of these materials. Coming back to physical models, through the book, I clearly found out that physical models had been used a lot throughout history, like in form finding of St. Paul's, for example, or we knew about Gaudi's work. But my question was like, how are they used today? Today we live in a digital society. One can't imagine our lives without digital tools. But the journey went further throughout history. That was also really rewarding because we could find out how physical models were used, and they had different roles in the projects. I love this by Frei Otto, thinking by modeling. But in more current project, like in Sambuichi's project, the Rocca Mount Observatory, the geometry was generated clearly through computational tools, through many iterations. But without models, they could not be sure that they would be able to put it together. Also, a lot of models were used to explore how the snowflakes will land and stay on this lace structure. A project that's now under construction is this water culture house. I don't know if you can see my cursor, but that's the School of Architecture. So it's very close to us. It's a bath, it's a spa building designed by Kengo Kuma architects and Zoran Jensen engineers. And clearly it's like a building at the forefront that couldn't have been designed without computation. So I was a little bit worried when I talked to the designers if they had used physical models. And what was really powerful that came across is that physical models are more important than ever. They're very different to what we know throughout history. They're now digitally printed, but they allow us to collaborate in the design team better than ever before. The book presented different roles of physical models. And again, it has 3 case studies. One of them is devoted to Mamoru Kawaguchi, one of my greatest heroes at IASS. Unfortunately, he did not live to see the text, but he's in the book. So that was a little moment about me.
Thanks very much, Olga, for taking us through all of those examples. There were some really fantastic projects you've been involved in or have been inspired in. It was truly fascinating to watch all of those. Thank you again for sharing those with us. On the subject of reciprocal framing, we did have a question from an audience participant on LinkedIn. So the question is, there are superb roofs and footbridges using the reciprocal framing principle. Are there other not so well-known applications of this technique?
I'm sure there are. The reason for that still people call them different names. When I started my PhD, it was very difficult to find references because of that the same reason. A lot has happened since, however. There has been a lot of application of reciprocal frames. However, a lot of them have still been in the domain of research. And one reason is that they're more complex to design, and often the resources are not, kind of the material resources have not been central to how we have thought engineering and architecture. So the short answer is, I'm sure there are many that we don't know about, and I hope that we will find out, and I hope that there will be more and more being built because they are safe, they give a distinct aesthetic, they are very versatile. But having said all this, a lot has happened in the last 10 years with computational tools development. So there is a whole community of reciprocal frame researchers, and I hope there'll be also designers, more of them.
Thanks very much for answering that for us, Olga. That was really appreciated. We're turning our attention in the final part of the interview towards IASS 2021, and we're asking all of our participants, what do you anticipate will be hot topics at IASS 2021?
I think hot topics will be aspects of collaboration, because although we have all the tools that allow for collaboration within the building profession, I think our values are still very different. So I think that collaboration will come at the forefront. Equally, I think if we look back 10-15 years ago, energy optimization was very important for buildings, but now we're able to design buildings that optimize energy use. However, resources and how we use resources is very important, is coming again at the forefront. So minimal structures, a very clever optimized design, where usability and accessibility and aesthetic values are combined with technical issues. Also, we need to think more about how we educate people, because these values are very much developed through education. And the current pandemic taught us lessons of how we can educate in different ways. But I think it's a very important topic. I think it has possibilities to develop further. In that sense, I think IASS brings people together that know each other. So it's kind of a club of people who take certain aspects and collaborate further beyond the symposium, but also it brings new young and old professionals who can have an impact on the profession and society. So all these aspects, I think, will be an excellent place to be explored and developed further at Surrey in 2021.
That's great. Thank you for that, Olga. And a key theme of the IASS 2021 conference is about inspiring the next generation. You are actively engaged in the education of engineers and architects. How can we continue to bridge the gap between these disciplines to positively impact the future of spatial structures?
Yeah, I think it's a life call, and something that we all work together with in the core group. I think the way to bridge the gap is to help each other understand the culture and the values, whereas after the Industrial Revolution, the two professions were really separate. In the years that have been in the last decade, because of new opportunities, but also new challenges, we have been able to work closely together. However, our values are still different. So I think understanding each other's values and kind of being able to appreciate them and to respect them will bring us closer to bridging the gap. If we also have a way to, or better ways to share and to work together. But again, the values are core, in my view.
Olga, thank you very much for taking the time to speak to us today. It's been really wonderful to get to learn a bit more about your career background and your interests. I've certainly learned a lot about reciprocal frame architecture today, so thank you very much for that. As I said, it was a pleasure to speak to you on the Movers and Shakers interview series, and hopefully as we get closer to IASS 2021, we could catch up with you again. But for now, thank you very much for speaking with us today.
Thank you also, it's been a pleasure. Thank you. Bye for now.